All right, class, in this lesson we're going to take a look at the metric system and converting between the metric and standard system that we use here in America. And what we're going to be dealing with is our units of 10, which is what the SI system uses, the metric system. And we're going to talk about how we as Americans just do such wonderful math. And of course, we have the best method, but you know, changing by tens is pretty doggone easy. But anyway, we're going to deal with converting between back and forth. And part of our problem is we just don't have a good picture of what these units look like because we don't use them in common practice. So we'll see this chart over and over. So we're basically going up and down by units of 10. So kilogram is by 10,000, and then all the way down to milli, which is dividing by 1,000. Okay, so we've got decameters to centimeters. So our job in our notes is to, in your assignment, is to take decameters, recognize where it is. So it's right here. So it's one bigger than our base unit, which would be meters here. And we're supposed to go to centimeters. So basically we've got to go over 1, 2, 3 places. And so that's actually what you can do with your decimal. You've got 5, and you're going to go over 1, 2, 3 places. The decimal is right here because it's 5.0. And so 5.0, fill it in with some zeros. What that means is you've got 5,000 centimeters. So 5 decameters is 5,000 centimeters. So let's talk about, there it is, 2,300 milliliters to hectoliters. So 2,300 milliliters means we're starting right over here, and we want to go all the way over to hectoliters. So if we just take the chart and count 1, 2, 3, 4, 5 places over in our 10, because we're going right past our liters. So we count over, again, that was 1, 2, 3, 4, 5 places, and we're multiplying by 10. So basically what we're doing is we're multiplying 2,300 by 10 to the 5th power. And if you do that on your calculator, it's just as nice as taking my 2300 and moving my decimal place to the left, because what we want to talk about is that milliliters is a very small measurement, and if we've got 2,300 of them, we're going to a very large measurement with hecto. So we're taking this and we're moving it this many places, 1, 2, 3, 4, 5 places, 1, 2, 3, 4, 5 places to the left, because this is a small part of a hectoliter. We have to fill it in with a 0. So what we'll see is that this is our equivalent from milliliters to hectoliters. The whole bottom line is you move it over as many places as the chart tells you to move it over from one to the next. So here we've got this wonderful description of where a meter comes from. Back in 1790, they originally called a meter a 10 millionth, there it is, 10 millionth of the distance from the North Pole to the equator. I'm not sure how they figured that one out. But since that time, we've redefined the meter into being this portion of a second of how fast light travels in a vacuum, and then measured that, and that gives us our current meter. So amazing math happening in the science world right now. But here is a good picture. This isn't actually, of course, on your screen what an inch looks like, or maybe it is, but depending on what the size of your screen is. But here's just the difference between inches to centimeters. So if I kind of put this right here, this will show me about where 1 inch is, and then 2 inches. And so we're used to measuring in inches if you're used to using your ruler much anymore at all. But this is our equivalence between centimeters and inches. Now, millimeters, if these are centimeters, 1, 2, 3, 4, 5 centimeters, millimeters are the little marks in between. And what's nice is that on our inches, we have 12 inches in a foot, and then we break these down into halves and then quarters, and we do all sorts of fun things on our inches, and we do all sorts of weird fractions. But the rest of the world just counts to 10. They're like, all right, you got 10 millimeters? All right, that's 10. So really this is 10 millimeters. And then if I count another 10, that's 20 millimeters. That's 2 centimeters. And so it's a much cleaner method. But anyway, a little picture of what this looks like in real life. If you had like the end point of a paper clip Of course, not this one. This would be about what a millimeter is, and then if you had the distance across, that would be from here to here. That's about what a centimeter looks like. So if you're looking at the common paperclip, that's what we'd be dealing with. So our job is to convert, is just to match what these shapes look like. So what 2 meter looks like and have a concept of it, and then 3 centimeters and 10 meters and 16 kilometers. And so we want to talk about it in our unit of math, and that would be feet. So 30 feet, 10 miles, and length of our bed, the thickness of this book, which you probably don't have because we have a digital copy, so it's pretty thin digitally. But anyway, so let's go with the book, since that one would be the smallest one. The smallest unit of measurement over here is centimeters, so this would be equivalent, or approximately, 3 centimeters. Length of our bed is probably, 8 feet, or 7 feet, or 6 feet, depending on how long your bed is. And so that would be more like 2 meters, because a meter is 3 feet times 2 is about 6. Pretty close. It's not exactly 3 feet. It's a little bit longer than that. So this would be close to 2 meters. And then the length of a 10-mile race, well, a 5K is 3.2 miles. So we've got 16 kilometers is probably closer to my 10 miles. And then finally a 30-foot yacht would be 10 meters. Okay, so just hopefully that gives us some equivalents, some approximations in our mind to visualize. Here we got 5 yards to inches. So here's where it gets fun for us, because this is the math that we're actually supposed to be able to do in America. And what we need to do is use my chemistry teacher way back when in high school showed me the goalpost method. The goalpost method, whether or not you like chemistry, worked for me. Hopefully it can work for you here. We've got 5 yards, and what we want to do is we want to convert that to inches. So inches needs to be over here at the very end, left over. So to make that happen, we want to figure out, well, how many yards, or how do I get yards to go away? In other words, I want yards down here on the bottom. So I need a in-between that shows me that yard turns into feet. So in other words, I have 3 feet is 1 yard. So 3 feet is 1 yard. And what happens is I'm going to be able to cancel out yards, cross-canceling, if you will, like a fraction, and I'll be left over with feet. In other words, right now I've got 5 times 3 feet is 15 feet. So right now, basically, I just took my 5 yards and turned it into 15 feet. Oops, that was supposed to be 1F, feet. So that's what this is showing up here, 3 times 5. And I want inches in the end. Well, what I know is that there are 12 inches in 1 foot. So what I want to do here is take my 15 feet and then times it by 12. So if I take and just multiply the numbers that are left, 5 times 3 times 12, oh, and I forgot to cancel out my feet. So if I cross out feet, because it's like cross-canceling a fraction, I'm left with 5 times 3 times 12, and if I multiply that out, 5 times 3 times 12, or if I just took the 15 and times it by 12, I get 180 inches. Okay, so this field goal, or there's just this bar way of doing it is a very convenient way of canceling out our units. Okay, so let's talk about this one, and the goalposts are already set up for me, so I'm just going to kind of talk through it here. Here we've got National Cookie Day. Sesame Street is making cookies, and they've got gigantic. It's 5 yards in circumference. How many centimeters is the circumference of this cookie? Well, to go there, we've got 5 yards, and what we want to do is set up our 5 yards. And what we need to know is that we want to get all the way over here to centimeters. So we set up our goalposts. So we want yards to cancel. One yard is 0.9144 meters, and then the 1 yard goes on the bottom. And so what happens is, now that I set this up, is that my yards can cancel, and I'm left over with my meters on top. Well, I don't want meters. I want centimeters. So to go from meters to centimeters, I know that 1 meter is equal to 100 centimeters. And so if I cancel out meters and meters, I'm left over with on the top what I want, which is centimeters. So here if I multiply, I'm left with 5 times 0.9144 times 100 centimeters. So now I just take that and do it on my calculator, and I get 5 times 0.9144 times 100 gives me 457.2 centimeters is how many centimeters it is around that cookie. Okay, so now we've got a similar problem here. We've got 0.3 kilometer, three-legged race. How long is this in feet? Because, of course, if we're in America, that doesn't make any sense to me, 0.3 kilometers. So I want to get this in feet. So to do that, I take my 0.3 kilometers, and again, you see it laid out here. I'm just going to basically be working through this. 0.3 kilometers. Over here, we see that a kilometer is very similar to a mile. I want my kilometers to cancel, so I want to say on top, I put equals, I didn't mean to put equals. I want to put my kilometers on a way so that they cancel out. Here they are on top, and I want them on bottom here. In other words, I want 1 kilometer to cancel. Okay, so to get that to cancel, I need 1.6 to be there. Even though it's not a 1, that's okay, because I'm going to have 1 mile up on top. And even though there's a 1.6 on the bottom, kilometers still will cancel. So now I just took my kilometers and canceled my kilometers, and I'm left over with the 1 on top here, the 1.6. So basically the math so far is 0.3 times 1 over 1.6, like that. So this is the math that so far it's going to happen. And I want to then take my miles and get it to cancel, because I want my miles to turn into feet. And we know that in 1 mile, there's 5,280 feet. And so that takes my miles, and they go away, and I'm left with multiplying by 5,280 to result in a final number that looks like feet. So we take our calculator and do 0.3 times, in parentheses, 1 divided by 1.6. In other words, you could have just multiplied 0.3, or take 0.3 and divide it by 1.6. And then we multiply that by 5,280, and that should give us 990 foot race. So 990 is the total length of that race. Right. So now let's talk about volume for metric measurement. And what we see is that here we've got a decimeter, and 1 liter is equal to 1 cubic. They call it 1 cubic. And 1 liter is we buy stuff that's a liter. We don't really know what that means compared to ounces, but 1 liter versus is 1 cubic, and they say that that's 1 decimeter is 1,000 cubic centimeters. So this is just going. So these are equivalent measurements here. So a decimeter is about 10 centimeters, or is exactly 10 centimeters. And so if we measure that, multiply that out, we get 1 liter. And to give us a little bit better frame of reference of what we're looking at size-wise, if we talk about a decimeter, if I take 10 of these and stack them up, that gives me 1 meter in length, because a decimeter is like our centimeters, but it's part of our centimeters. If I have 10 centimeters, I get a decimeter. But anyway, if I have a whole meter out here and multiply by 1 meter up tall, so you can think of a meter stick, if you will, and multiply 1 meter by 1 meter high by 1 meter deep, then I would fit in 1,000 liters into a cubic meter. So that's about the size that we're talking about. 1,000 of these liters that we buy at the store would make a cubic meter. And again, the bottom line here is that the liter is the basic unit of measurement for volume. And here we've got to estimate the volume of each of the following items with these measurements of milliliters, 250 milliliters, 100 liters, 500 meters cubed, and 1 cubic decimeter. So, talking about a gas tank of a car. So if we take a look at the gas tank of a car, 100 liters is about 100 quarts, in other words, 25 gallons. It's about the same size as a tank, medium-sized gas tank for a car. 25 gallons, maybe you've got a smaller, bigger tank. But that's about 100 quarts or 100 liters here. Large pile of gravel at a construction site, that would look like 500 cubic meters, and that's 500 cubic yards. Usually you buy gravel or concrete in yards, and so it gives you a nice sized pile of gravel. A glass of soda would be about a quarter of a quart, a fourth of a quart, and a quart is about a liter. A liter is 1,000 milliliters. A glass of soda has a volume of about 250 milliliters. So it's just kind of giving some equivalents if you want to just stare at that for a while and give yourself a good concept of what these cubic meters, how it kind of references to our actual current measure system. And last one, a quart of orange juice is roughly a liter, and that's 1 cubic decimeter, so the volume of an orange juice is about 1 cubic decimeter. So about a liter is probably the best way to look at that. But we've got a situation here, and this is how you're going to be looking at your assignments. Is you've got 4 bottles, and they each contain 0.35 liters of a flu vaccine. Each vaccination for each person takes 2 milliliters of the vaccine. So how many patients can be treated with the amount of vaccine the clinic has on hand? So what we need to know is that, first of all, we need to multiply our 4 times how many liters we have. So we've got 4 times that, and so that's going to give us 1.4 liters. And so that our job is to turn this into milliliters, because each person takes 2 of them. And so we take and move the decimal place 3 places over, so 1.4. Move it over 1 place, 2 places, 3 places, so we've got 1,400 milliliters. So if we're trying to figure out how many people can be treated with that amount, well, we take our 1,400 milliliters and divide it by our 2 that it takes to do each person, and that's going to give us a wonderful amount of 700 people that can be treated with this flu vaccine. Okay. So now we're going to talk about converting between standard and metric volume. These are the relationships that we probably want to stare at for a while, and it also pops up when you're using your questions on lab if you click that little button for conversion charts, and we're going to be asked problems about these. So here we've got an American gas tank with 23 gallons in it, and you're asked if, okay, if I drew this all the way to France, how many liters of gasoline would I need to be buying? Because they're not going to sell you a gallon of gas, they're going to give you liters. And so our job is to convert. And so we set up our nice goalposts that we were doing in the previous problems, and we've got to convert gallons to our liters. So here, we want to go ahead and realize that gallons needs to first turn into quarts, and we know that quarts gives us liters. So we've got over here this guy. So we want to use this box and this box that are highlighted for us. And so we've got to set up our 23 gallons. We need gallons to cancel. So we multiply it by 4 quarts and divide that by our 1 gallon. And then we're going to be left over with quarts. So we multiply that by 0.9464 liters. I'll say big L. And then you're dividing that by 1 quart, because 1 quart is the 0.9464 liters. So what happens is my gallons cancel, and then my quarts will cancel, and so all that's left over is numbers and liters. The numbers, when I multiply them, will tell me how many liters I have in total. So 23 times 4 times 0.9464 gives me a total of 87.07 liters is how much gas I would need to buy in France. Okay. So another problem that you're going to see in your assignments. Holding pond at a fish hatchery is 11 meters long, 9 meters wide, and it contains 660 kiloliters of water. How deep is the pond? Well, it's important to know that a kiloliter is 1,000 liters and 1 cubic meter. So if this is 1 cubic meter for 1 kiloliter, then I've got my problem here is that meter cubed, this is what I want to be focusing on, would be meters times whatever meters I'm missing. In other words, I've got 11 times 15 times the depth of the pond, which we'll call D, would give me my 600 kiloliters. Cubic meters is basically. So kiloliters is equal to cubic meters. It's basically what we're getting after here. And so this is basically what would have happened. Is I'm basically multiplying the length times the width times the height of this shape to get 660. So, and again, that's because kiloliters is basically the same thing as cubic meters. And so cubic means I have meter times meter times meter. And so that'll give me the cubic meters here. In other words, bottom line, you have these three numbers that need to be multiplied, and it gives you 660. So if I undo that, in other words, if I get D alone, I divide both sides by 11 times 15, it will leave me with what D is. So 11 times 15 is 165. So basically D is equal to 660 divided by 165. So 660 divided by 165 gives me 4. So my depth is 4 meters at this fish hatchery pond. All right. So let's convert mass. It's the last type of measurement we need to deal with. Here's your conversion chart. And so we've got a contractor refurbishing a church, has ordered slabs of Italian marble. They weigh 1.8 metric tons each. He wants to rent a crane to lift the slabs of marble. How much in pounds should the cranes be able to lift? That is an important thing because cranes can only lift so much. So we've got 1.8 metric tons, and put MT for metric tons. And then how much in pounds? So we want to get to pounds eventually. So over here we've got to have pounds. So metric tons gets us to kilograms, and kilograms gets us to pounds if we're looking at the chart here. So what that means is I want to multiply by 1,000 kilograms, and that will make my 1 metric ton cancel. And then I can get my kilograms to cancel if I put the kilogram on the bottom, and that gives me 2.2 pounds. And notice now that's it. I'll be left with pounds. So now my metric tons will cancel out the way that I've got them set up, and then my kilograms will cancel out like this, and then I've got pounds left over. So I take all the numbers that are left, 1.8 times 1,000, 2.2 on my calculator, and that will give me the pounds. So I take 1.8 times it by 1,000, and then times that by 2.2, and I get 3,960 pounds, or LBS for short. Explain that one. All right, there's the work PowerPoint. All right, so there's our answer. If you have any questions in this section, this is all I've got for you. So if you have any specific questions or problems, let me know through the Ask My Instructor feature of the lab.